Hello guys, today this is the day before Further Maths Paper 1, the real Further Maths Paper 1 this time, and we're going to be going through every single thing here, every single thing that you need to remember, every single thing you need to do in Further Maths, not including stuff from normal maths. We're just going to go through it in this document here. So we're going to just get right into it. So firstly, we start with some of the easier stuff, factor theorem. So with factor theorem, if we know the first principle of factor theorem, so if n is a solution, if any number is a solution to any cubic or even a quartic, if that comes up, which probably won't, but if n is a solution to any cubic, which just means that f, or if you substitute n into that cubic, it equals 0, then x minus that number is a factor. And we can use this in long or in division, like this, algebraic long division. Now, some schools learn different methods for this, but this is my method to doing it. So you look at this, you write the thing you're dividing through on this little bit here. You write we're dividing. Then in the middle, you write the first term. Obviously, this is the cubic that we're dividing from, or this is the cubic we're dividing. So we think, what do we need to multiply to 2x to get 6x cubed? Well, 3x squared. So 3x squared. Then you multiply this like a grid. So you get negative 9x squared. Then you think, what do you need to do to get from negative 9 to negative 25x squared? Well, you need negative 16x squared. Then you do the same thing you did from earlier. What do you multiply by 2x to get negative 16x squared? Well, negative 8x. Then you multiply, get 24x. And then do the same thing. What do you need to get to 28x from 24x? Well, positive 4x. Do the same thing. What do you need to do to multiply 2x to get 4x? Well, just 2. And that's your quadratic right there that you've just divided from this cubic, 3x squared minus 8x plus 2. Right, next we've got binomial expansion. So this is Pascal's triangle. You should be able to just derive this in the exam, but just as a reminder. Now, if we look at this binomial right here, 3x plus 2 to the 4, the power tells you the amount of terms, well, one more than the power, so there'll be 5 terms in this, as you can see. I've drawn a table. So if you write the 2 terms here, so 3x and 2, they're the 2 terms, you go up in powers. So let's say we'll go up in powers for this one. So this is 3x to the 0, this is 3x, and then we square it here to get 9x squared, then we cube it to get 27x to the 3, and then we to the power of 4 get 81x to the 4. Or obviously we know 3x to the 0 is just 1. Then we do the opposite for 2, so we start at 2 to the 4, which is 16, then we go down, so we get 8, and then we get 4, and then we get 2, and then we get 0, because it's 2 to the 0. Then what you do, all of these column lines represent adding. These will represent adding, and then these lines represent multiplying. So what you do, you multiply all the terms in each column and then add them together. So in the first row it's just 16, the next row it's 4 times 8 times 3x, which is just 96x, and then you multiply 6 times 9 times 4, and then you do the same thing for each of these terms while keeping the x's as well until you get to the last term, which would just be 81x to the 4. And that is how you do Pascal's triangle. Sometimes they give a lot of convoluted questions where they ask you to find one of the coefficients. All you have to do there is just do whatever it's asking. Just firstly expand the what it says instead of just saying like, oh, the term of x cubed or the term of x squared, or there'll be 2 different binomials and you have to find a value. Just expand them first, and then you can work off that, because it will give you most of the marks and it will tell you what to do later in the question. Alright, let's move on to the big topic, differentiation. Well, this is by far the biggest topic, there actually isn't that much here. So, firstly, what is the derivative? This is different ways that they can write to do the derivative or differentiate in the exam. They can say f dash of x, they can say the rate of change with y with respect to x, they can say that, or they can just do the normal dy by dx, as you might know. And next, this is how you simply derive something. Use the power rule, you should probably know this. You just multiply by the power and then subtract 1 from the power. And this is the gradient of any line. So if it's asked you to find the tangent, this will be the gradient of the tangent. If it tells you to find the gradient at any point, this is the gradient at that given point. Next, if you need an increasing function or a decreasing function, that means the gradient will be greater than 0. So for an increasing function, dy by dx is greater than 0, and then you solve it. And then for a decreasing function, dy by dx will be less than 0, and then that would be your answer. When you set whatever the derivative is of whatever function you're deriving to less than 0 or greater than. Next, for stationary points, you set it equal to 0, because if you think about it, it's when the gradient does equal 0, it's when the gradient stops, it's when the function stops increasing or decreasing. Next, finding maximums and minimums. You use the double derivative, just derive again. With a maximum, it's when it's less than 0. For a minimum, it's when it's greater than 0. If you ever get a function, if you ever get like a cubic or above, where the double derivative still contains an x, then you just substitute the point, substitute the stationary point in that you're trying to find if it's a maximum or a minimum. Because with quadratics, it will just be a number, but with cubics and above and orders above cubics, you would have to substitute the point in, the x value of the point. Alright, next we are going to go on to the other topic, big topic, matrices. So this is something that a lot of people don't actually learn, that a coordinate is just the same as a column vector, but the teachers kind of just throw this in there and expect students to instantly get it. Just clarifying this. Next, this is multiplying 2 by 2 matrices. You should be okay at this. It looks a bit complicated here, but if you think about it, you're just multiplying each row by each column of the slot you're in. If you just pause the video and take a look at how you multiply this. Next, the identity matrix. This is this matrix you have to remember. It's the only matrix you actually have to remember. And it just means that if you multiply this matrix by any other matrix, the A's and the B's here represent matrices, it will just give you the original matrix. Doesn't matter if it's before or after the original matrix. Next, multiplying matrices is not commutative, so B times A, when they're both matrices, does not equal A times B. If they're both matrices, they are not commutative. Then you might get a question asking, like saying, prove that they're not commutative by using these certain matrices that they give you. You just multiply them both ways, and you say, oh, well, they're not the same, so it's not commutative. Next, the matrix transformations. This is where it gets a bit more difficult. So, if you want to rotate this 90 degrees clockwise, you take the 2 points from the identity matrix and plot them on a graph like this, in a kind of square pattern for the unit square. And then you rotate this square 90 degrees clockwise, so it's going to be like this. And then you think, where do these points end up? So the 1, 0 has ended up in 0, negative 1. And the 0, 1 has turned into 1, 0. These are the new points. So now, what the first point in the identity matrix is 1, 0. So the 1, 0 has gone to 0, negative 1. So that will be the first point. And then the 0, 1 has turned into 1, 0. So that will be 1, 0. And then that is your transformation matrix. This is one of the more tricky topics, so I would definitely do some practice questions on this. Maybe with combined transformations as well. Just make sure to always do the last transformation first. Whatever your matrix you're transforming something by, you do that one first, which is kind of opposite logic, but you just have to remember that. Right, last topic, we have trig. So this further trig stuff, it does catch a lot of people off, so we'll go maybe a tad bit slower. So firstly, we have sine. You need to remember the graph for all of the trig functions. Surely it's not that difficult to remember. You just have to remember that they're waves, and you just have to remember where they all end up. You also need to remember that sine repeats every 360, same with cos, and that its range is from 1 to negative 1. Alright, for cosine, it looks kind of like a bucket, the cos bucket, where it'll start at 1 and it will end at 1. That's something easy to remember with sine and cos. Sine starts at 0, ends at 0. Cos starts at 1 and ends at 1, both at 360 degrees. And tan is a different one, where it asymptotes at 90 and 270 degrees, or every 180 degrees after 90 degrees. It asymptotes because it infinitely goes up in this direction until it reappears at the bottom here. And tan repeats every 180 degrees instead of 360. Now, for you over here, we know the sine of any angle is just the sine of 180 minus that angle, because you can kind of prove this here. If you see an angle here, it will be the same as this angle here, and because it's the same height on the sine graph. And then for the same for cos, you can find this angle and then you can kind of replicate it on the other side of the cos graph. And then with tan, because it repeats every 180, you can just do 180 plus the angle, and this would be basically, these would be the same angles. All right, we're going to quickly go through trig ratios now. So this is purely for non-calc because this can't come up in calculator unless it tells you to like show you're working. So if it tells us that sine of x is 4/5 and it is obtuse, I forgot to write down the question. You need to find cos of x. What you do first, you draw the graph of what you're trying to find, not the original one, and you see that the obtuse range is from 90 to 180. So you draw the lines here. This is 90, this is 180. You see the cos graph is fully negative, so we know that our answer is going to be negative. Now you draw the triangle out, so this would be theta, and then you know that sine is opposite over hypotenuse, so it would be 4/5 like this. You use Pythagoras to find the other side because it's going to be a right angle triangle. This is a Pythagorean triple, so it will be a whole number. But you can just do Pythagoras in your head if it takes a bit, because you do have enough time in further maths exams. They give you a lot of time for these ones. And when you do this, you think about cos, it's adjacent over hypotenuse, and then you will divide that by, you will do whatever is on this triangle, and you will get cos x is negative 3/5 because of this. Next, finally, we have the identities, and these are the two identities that you do get on your formula sheet. However, if you don't remember them from all the practice questions you should have done, or even if you didn't, from being taught them, as there only is two, you should be able to remember them. But even if you don't worry, because they are on the formula sheet. And you can obviously rearrange these, so this one's much more useful to rearrange. So cos squared equals 1 minus sine squared. And then how to actually do these questions. This is what I have made up, this method I have made up, which is fates. You can watch my video about it if you want. The previous video I made is all about this, and I added some questions as well. You would do this backwards. So whenever you see a trig identity question, you think, is there any special methods I can use, like difference of two squares? Then you think, oh no, there isn't. So is there a tan that I can turn into a sine of a cos? And then you think, can I use this identity over here? That's the I. And then you think, can I use any algebraic fractions? Can I turn it into a fraction that I can combine, or can I factorize anything out of it that I can cancel out? Just something I wanted to add is that people forget, is that cos over sine equals 1 over tan, because if sine over cos equals just tan, then cos over sine would be 1 over tan. It's just something that a lot of people forget, and it's a thing that a lot of people lose marks on. Alright, thank you for watching, guys. I haven't gone through any like the smaller topics, the more like kind of, I'm not going to say common sense easier topics, but just like smaller topics like product rule for accounting and domain and range and piecewise functions. But you can always go through them in exam questions and stuff like that. These are just the big main 5 topics in further maths, so that I've gone through here. Thank you for watching, and I will see you guys in the next video.